By the early 1970s, deep in the American mining sector, a machine appeared that looked wrong even before it moved. The Dart 600, introduced in the mid-1970s, was neither a conventional wheel loader nor a standard underground hauler. It was a low-profile, articulated mining loader built around a radical idea: bring massive front-end loading capacity into spaces never designed for it. A period dealer brochure described it plainly as designed to move rock where standard loaders cannot operate. But the numbers told a stranger story: a machine weighing well over 60,000 pounds, carrying multi-yard buckets, built to work beneath ceilings that punished tall equipment. Operators remembered the sound first: a deep diesel note echoing off tunnel walls, hydraulic pressure hissing inches from their boots. It could outlift anything its size underground. It could outpush machines twice as common. And yet today, almost no one remembers the company that built it. How does a machine that solves a real problem brilliantly still disappear from the industry it tried to change? By the late 1960s, most underground mines were still working around equipment never truly designed for confined rock. Modified surface loaders scraped ceilings. Cable machines forced maintenance crews to work harder. Downtime was accepted as a cost of doing business. Dart began as a specialty industrial equipment builder, rooted in small batch fabrication and mining adaptations rather than mass production. Early leadership included hands-on engineers and field salesmen who had worked directly with mine operators, men who understood that every inch of tunnel height mattered more than horsepower specs in a catalog. Internal sales literature and early dealer sheets emphasized custom solutions for restricted operations, language that spoke to mine foremen tired of forcing square machines into round holes. They survived by solving niche problems giants ignored: reinforced frames for abrasive rock, simplified hydraulics for cold weather reliability, and service access designed around actual maintenance schedules. The industry did not want revolution, it wanted survival underground. Underground coal and hard rock mines faced the same constraint between 1969 and 1971. The constraint was height. Standard loaders wasted power, ducking instead of lifting. Buckets were downsized to fit headroom. Cycles slowed as operators fought articulation limits near timber supports and roof bolts. Manuals from the era warned operators to avoid full articulation near roof supports, a quiet admission of bad fit between surface-bred machines and subterranean reality. Across the Illinois and Kentucky coalfields, contractors were losing tonnage, not to equipment failure, but to design mismatch. Caterpillar and Deere dominated surface work, but underground remained fragmented. Dozens of regional builders offering modified solutions, none quite right. The economics were brutal. Every additional pass through a loading cycle meant lost wages, diesel fuel, and competitive edge. If you could lower the machine without lowering output, you owned the job site. Lower was not weaker, it was freedom. Before the 600, Dart earned credibility with smaller, purpose-built mining machines in the early 1970s, serviceable, repairable, and dealer-supported within limited territories. Regional dealers acted as field testers, feeding back failures and fixes from Minnesota iron ranges and Michigan copper country. These weren't showroom salesmen, they were often former operators or mine mechanics who kept welding rigs in their service bays and understood that a machine's reputation lived or died on uptime between parts orders. Dealer manuals stressed accessibility, all service points reachable without lifting equipment, a promise that mattered more in a wet tunnel than any brochure photograph. Trust came from uptime, not branding. A superintendent didn't care about the name on the hood if the loader was pulling rock while the competitor's unit sat cold, waiting for a hydraulic line from 3 states away. That trust made the next decision possible and dangerous. Around 1973, Dart committed to a radical idea: a large capacity, articulated, low-profile mining loader, not a compromise machine, but a purpose-built underground brute. The engineering risk was immediate. Lowering the frame meant rethinking driveline angles, cooling airflow paths, and hydraulic routing through tighter spaces. Patent filings and design drawings show extreme articulation geometry, the kind that required custom joints and reinforced pivot pins to handle the torque loads of a multi-yard bucket twisting through broken rock. Every inch shaved off the roof clearance added pressure somewhere else in the system. Literally. Bearing loads increased. Heat dissipation became critical. The cooling package had to function in dust-choked air with minimal vertical space for radiator stacks. It was engineering at its finest. Tight integration, purposeful compromise, obsessive attention to the stresses that killed machines in the field. But engineering alone does not pay the bills. The Dart 600 entered the market in the mid-1970s. Operating weight exceeded 60,000 pounds. Bucket capacity reached multiple cubic yards, varying by configuration and application. Articulation was extreme, designed for tight headings where conventional loaders could not rotate without striking timber or rock. Power came from a high horsepower diesel engine tuned for torque delivery at low revolutions per minute. The kind of grunt needed to break loose, compacted muck, and drive uphill through narrow drifts with a loaded bucket. Picture it, a bucket filling the entire frame of a narrow drift, the boom shadow scraping the roof. The machine folded nearly in half as it backed away from the pile. Trade advertisements highlighted maximum breakout force and minimum height, a claim that was not marketing poetry but measurable hydraulic pressure translated into bucket curl force. It fit where nothing else could, and it moved rock like nothing else did. Operators noticed immediately between 1975 and 1977. Dealer surveys and trade write-ups praised cycle time improvements and pushed power in confined headings. The hydraulic hiss became familiar background noise, mixing with the grind of crushed stone against steel, bucket edges, and diesel exhaust, echoing through rock passages that amplified every mechanical sound. One operator's testimonial appeared in regional mining equipment reviews. The machine handled like it was built for the space, not forced into it. Fewer passes per pile meant fewer hours per shift, which translated directly into cost per ton, the only number that mattered when contracts were bid thin and fuel prices climbed. Productivity improvements like that don't stay secret. Mine supervisors talk. Contractors compare notes at equipment auctions and industry gatherings. Word spread through the underground mining community that Dart had built something genuinely different, a machine that finally matched the job instead of fighting it. Dart expanded cautiously through the late 1970s, offering bucket options for different rock types, reinforced frames for abrasive conditions, and mining-specific attachments that addressed job site requests. Production numbers remained small. Dealer networks stayed regional, concentrated in areas with active underground mining operations. They were not chasing national coverage. They were serving known customers with documented needs. But giants watched quietly. They always do. Caterpillar had the scale to absorb development costs across product lines. Case and Deere had dealer networks that reached into every mining district in North America. When a small manufacturer proves a category, the question is not whether the giants will enter, it is when and with how much capital behind them. Innovation does not need advertising when it works. Operators demonstrate capability every shift, and purchasing agents pay attention to cycle times and maintenance logs. The Dart 600 was advertising itself on job sites across the Midwest and Appalachia. Someone was taking notes. Despite documented performance, limitations appeared as the 1970s progressed. Parts logistics were slower than competitors with national distribution networks. Dealer reach was thin compared to Caterpillar's infrastructure or Case's established mining equipment presence. When a hydraulic pump failed in a Wyoming hard rock mine, the replacement might take days instead of hours. Contractors loved the machine, and superintendents praised its capability in trade journals and dealer feedback reports. But accountants worried about resale value. Fleet managers calculated risk differently than operators. A machine from a small manufacturer, no matter how well engineered, carried uncertainty in secondary markets. Banks financing equipment purchases asked harder questions about long-term support and parts availability. The economics of being small and specialized began to work against the same focus that had created the breakthrough. Being right about the engineering was not the same as being safe in the market. The Dart 600 proved the concept beyond doubt. With a full bucket and an articulated frame that could twist in a confined drift, the machine moved through spaces that would have stopped conventional loaders cold. It was not just capable, it was dominant in its specific environment. a purpose-built answer to a problem the industry had been working around for decades. Operators who ran it understood they were using something genuinely different, not a modified version of something else. The machine delivered what the brochures promised, which was rare enough in heavy equipment to build lasting credibility. They had built the future, demonstrated it in dozens of underground operations, and shown the industry exactly what was possible when engineering focused on a specific constraint instead of general markets. The proof was undeniable, the performance was documented, the concept was validated. That was the invitation. Major manufacturers introduced low-profile underground loaders of their own through the late 1970s and early 1980s. The designs varied, but the core concept was identical: bring high-capacity loading into restricted height environments through articulated frames and repositioned components. They arrived with advantages DART couldn't match, including better financing terms through captive finance arms, deeper dealer networks with parts depots in every mining region, faster delivery on replacement components, and established relationships with large mining contractors who preferred vendor consolidation. Standardization beat originality. Fleet managers chose consistency over brilliance because consistency meant predictable maintenance costs, known resale values, and single-source negotiations for entire equipment fleets. The category survived. The pioneer did not. What DART proved in the field, the giants commoditized through scale. What made the DART 600 special became normal within half a decade. Low-profile articulated mining loaders appeared in every major manufacturer's catalog. The engineering solutions DART pioneered, including tight articulation geometry, repositioned cooling systems, and optimized hydraulic routing, became industry-standard approaches. Innovation became invisible once everyone copied it. The machines kept working in mines across North America, some still carrying DART badges on frames that would outlast the company that built them. But the name faded from dealer signs and trade advertisements. The category DART created no longer needed DART to exist. The market had absorbed the lesson and moved on, and invisibility is lethal. The early 1980s delivered a double blow. Recession tightened capital equipment purchases across the mining sector. Metal prices dropped, mines curtailed operations, and contractors delayed equipment replacement. Competition simultaneously squeezed margins as major manufacturers fought for diminishing market share with aggressive pricing and financing incentives that DART could not match. Internal strain followed. Ownership shifts, branding dilution, and shrinking production volumes set in. Final brochures grew quieter and claims softened. The confident technical language of the mid-1970s gave way to more cautious positioning. Engineering specifications remained strong, but market presence weakened. The machine still worked, cycle times stayed competitive, hydraulic systems remained reliable, and frames held up under tonnage that would have broken lesser equipment. But the business did not. Today, the DART name is mostly gone. The company faded through acquisition, merger, or simple market exit. The records are incomplete, and the exact sequence is unclear, but the low-profile articulated mining loader is everywhere. Walk through any underground operation, and you will see the descendants of what DART proved possible. Tight articulation geometry, optimized component placement, and purpose-built underground capability. A rusted frame might sit in a Montana equipment yard, paint worn off, but structure still sound. A faded brochure in a dealer archive. A control lever design still copied in modern machines. They did not lose because they were wrong. They vanished because they were first.